IP addressing is related to IP protocol. IP addresses are unique addresses which are given to the packets when they move on the internet from one system to another. These IP packets are having IP addresses which we have done earlier. So now we have to see that how this IP address is related to IP protocol. And what is a protocol? Protocol is the agreement, a set of rules which are used for exchanging messages, data between various computers, devices which share different hardware and software. So we can define a communication protocol to be an agreement that specifies the format and meaning of message computers exchange and the appropriate actions required for each message. There are many protocols which are being used on the internet. Some of them are listed over here, like Digital Equipment Corporation, DEC company has created the protocol suite DECnet. Novell has given NetWare, IBM has given SNA, and there are many vendors, and the most commonly used protocol is TCP/IP. So what is a TCP/IP protocol? TCP/IP protocol is a protocol which is end-to-end, which is responsible for end-to-end transmission of data. It is having layered format, means that the uppermost layer or application layer treats the data packet first, then the data is treated by the transport layer, further it is treated by internet layer, and then is treated by network interface layer. That means data, once it is finalized to be sent to the destination, is treated many times, and every time when it is treated, some extra control information is added to the data so that when it reaches the destination, it can be unwrapped in a similar manner. Let's say, for example, we have application layer. Application layer has the data, and transport layer. At transport layer, either UDP header or TCP header is added so that the packet can be next treated by the network layer. In the network layer, we have IP protocol which treats the data packet and forms a IP packet. Further, in the last working, we have host to network layer which creates the actual data packet which is to be transferred. Now here, if we look at the IP header format, what is the IP header format? IP packet creates IP data packet. IP protocol creates IP data packet, and this data packet has got IP header and the data. As we can see over here, we have at the top, we have these few header fields, and these few header fields are then followed by data. So our IP protocol will create this kind of a packet which has got some fields which is actually control information, which will be followed by data. Now let's have a clear look of each of these fields. The version field. This is the first field of IP header. This specifies that which version of IP is being used. There are two versions of IP protocol. One is IPv4 and another is IPv6. So if the version 4 is being used, the value will be 0100, which is equivalent to 4 in decimal. Next field is header length field. Header length field tells the length of the header over here. In terms of bytes, it is between 20 to 60 bytes. And in terms of lines, it is 5 to 15 lines. So accordingly, whatever is the length of the header of IP packet, the value is written. Next is TOS. This TOS field means type of service field. Now what is this field? This field actually specifies the value in order to tell the router that what kind of treatment should be given to the data packet. Like say for example, if we have this diagram, we can see over here that from the source the data moves, and through that when it reaches the destination, on the way there may be congestion at any of the router, there may be delays at some of the routers. So in these situations, there are some packets which we want should go early, and there are some packets which can be discarded. So the priority level can be set in the packet itself. The value is put at the source, and on the way it is analyzed by the various devices like routers and gateways. Accordingly, the treatment to the packet is done. So that is how type of service field tells how the service should be provided to the packet. What kind of service should be provided to the packet. Next field, total length field, is 16 bits field. So that means the maximum value which can be written on this is 65535, and that's the maximum length of IPv4 datagram. The datagram cannot be more than this. The size can be only 65535. So as per the size of the IP datagram, the value is written over here. The next three fields are related to each other: identification, flags, and fragment offset. These three fields altogether mean that routers on the way have fragmented datagram. Like taking the example of this diagram once again, what we can see is from the source to destination, as the data moves, there is one router which is marked in a different color. This may be a router which is not able to treat a bigger data packet, or which may not be able to treat a packet of the size which it is of. So it may be an old router, or there may be the version difficulty. So what we have over here is this router has the capability and has the right to fragment the packet into datagram into smaller fragments. In this case, how the smaller fragments will be put together? These will be put together by using the three values: identification, flags, and fragmentation. Identification means to which datagram actually it belongs. Was it first? Was it second? Was it 10th part of the file? And flags have some value regarding whether it should be fragmented or not fragmented. Fragmentation field is related to the offset value where the datagram has been cut. Now here we can see the next field is time to live. The time to live field is a field which is deciding the limitation of the existence of packet on the network. A datagram should have a lifetime. Otherwise, if it loses its path, it may be just bouncing off the places and the network will get jammed, because there are many packets, there are many datagrams on the way, and they lose their path, there may a time may come where all these will create congestion. So time to live field actually is a misnomer term because it is related to the number of hops and not to the number of minutes or seconds. It simply tells that if a packet has taken so many hops, X number of hops, it should be removed from the network. As it goes off the network, the congestion will go away. The simple policy over here which is maintained is that as the packet moves from source to destination, approximate number of hops are known to it. So the number of hops are written in the time to live field and the value is subtracted by 1 when it moves through every hop, through every router. The moment the value becomes 0, the packet will no longer remain on the network. So this is a value which is written to remove the packet datagram which is no longer required and has lost its path. Protocol is a field which is 8-bit field and it tells that which is the upper level protocol, like at the upper layer which protocol, either TCP or UDP, has been added, has been taking care of this datagram. Now the field header checksum is a field which is required to compute the value at the source and also at the destination to check whether is it the same data which is sent or has it been corrupted on the way. There are different methods of checking the error, and one of the most commonly used method is header checksum. Header checksum method is similar to CRC method, and it checks whether whatever data is transmitted has been received by the destination. If there is a change, it is informed and a negative acknowledgement is sent at the source so that retransmission can continue. Now what we have is IP address. We have done it earlier. An IP address has 4 dots, 4-byte address which has a value between 0 to 255. Source address is that address from where data has come, because we know now that an IP address represents every device on the internet uniquely. So source address is that value which is the IP address of the source, and similarly destination address is the 32-bit or you can say 4-byte value which is for the device or the system which will be receiving the data. So this is how our IP data, IP header format completes. Thank you.